Whenever we apply a modifier to a SwiftUI view, we actually create a new view with that change applied. We don't just modify the existing view in place. If you think about it, this behavior makes sense. Our views only hold the exact properties we give them. So if we set the background color or font size, there's no place to store that data. We're going to look at why this happens in the next chapter, but first I want to look at the practical implications of this behavior. Take a look at this code. Button, hello world. Comment do nothing. Dot background, color dot red. Dot frame, width 200, height 200. What do you think that will look like when it runs? Chances are you guessed wrong. You won't see a 200 by 200 red button with hello world in the middle. Instead, you'll see a 200 by 200 empty square with hello world in the middle and with a red rectangle directly around hello world. You can understand what's happening here if you think about the way modifiers work. Each one creates a new struct with that modifier applied, rather than just setting a property on the view. You can peek into the underbelly of SwiftUI by asking for the type of our view's body. Modify the button's action to this: print type of self.body. Swift's typeOf method prints the exact type of a particular value, and in this instance it'll print the following: modified content, button, text, background modifier, color, frame layout. You can see two things here. First, every time we modify a view, SwiftUI applies that modifier by using generics. Modified content, our thing, our modifier. Second, when we apply multiple modifiers, they just stack up. Modified content, and so on. To read what the type is, start from the innermost type and work your way out. The innermost type is modified content, button, text, background modifier, color. Our button has some text with a background color applied. Around that we have modified content, frame layout, which takes our first view, the button and background color, and gives it a larger frame. As you can see, we end with modified content types stacking up. Each one takes a view to transform, plus the actual change to make, rather than modifying the view directly. What this means is that the order of your modifiers matter. If we rewrite our code to apply the background color after the frame, then you might get the result you expected. The best way to think about this for now is to imagine that SwiftUI renders your view after every single modifier. So as soon as you say background color.red, it colors the background in red, regardless of what frame you give it. If you then later expand the frame, it won't magically redraw the background. That was already applied. Of course, this isn't actually how SwiftUI works, because if it did, it would be a performance nightmare, but it's a neat mental shortcut to use while you're learning. An important side effect of using modifiers is that we can apply the same effect multiple times. Each one simply adds to whatever was there before. For example, SwiftUI gives us a padding modifier, which adds a little bit of space around a view so it doesn't push up against other views or the edge of the screen. If we apply padding, then a background color, then more padding and a different background color, we can give a view multiple borders, like this. Text hello world, dot padding, dot background color dot red, dot padding, dot background color dot blue, dot padding, dot background color dot green, dot padding, dot background color dot yellow.